Hello, dear learners! Are you ready for another fun and exciting learning experience today? Come, let's deal with numbers.
Today, you are expected to define and describe experiments, outcome, sample space, and event. Determine the outcomes of the experiments, sample space, and event. Illustrate an experiment, outcome, sample space, and event. Apply the concept of experiment, outcome, sample space, and event to real-life situation.
For our first activity, let's play Vortex one word. The game mechanics is that you need to guess what the word is by looking at the four pictures with the one common word. Number 1. Can you guess what the word is? The answer Number 2. Look closely at the pictures. And the answer is very good. Number 3. What do you think will be the answer? The activity has a great connection for our topic for today, which is experiment, outcomes, sample space, and events. But first, let's define the following key terms. Experiment is a process leading to exactly one of various possible outcomes. It's an activity with an observable result. Tossing a coin, rolling a die, throwing a die and a coin together, selecting a card on the standard deck of cards. Let's now define outcome. It is also called a simple event or a sample point. The things that can happen in an experiment or the result of an experiment. Let's now define sample space. It is also called the probability space. The set of possible outcomes, sometimes denoted as, or the set of the different outcomes coming from experiment. That is sample space. Let's get to know event. It is a subset of the sample space that is a set of sample outcomes, sometimes denoted as A.
What's the chance of rolling snake eyes? What's the chance of flipping heads 3 times in a row? When calculating the probability of 2 or more events happening together, we can use the multiplication rule of probability. We'll start with independent events, where one event's outcome has no effect on the other event's outcome. For example, what's the probability of rolling snake eyes? Each roll is an independent event because the value on one die has no influence on the value of the second die. The multiplication rule of probability says that the probability of 2 events, A and B, happening together is the probability of event A multiplied by the probability of event B. In this case, the probability of rolling a 1 on the first die multiplied by the probability of rolling a 1 on the second die. This is the case if you're rolling the dice together or one at a time. The probability of rolling a 1 on a die is 1 out of 6, so the probability of rolling a 1 on both dice is 1/6 times 1/6, or 1 out of 36. Across all 36 possible rolls of 2 dice, one of them is snake eyes. Let's look at a second example. What's the probability of flipping heads 3 times in a row? Well, it's the probability of the first flip landing heads multiplied by the probability of the second flip landing heads multiplied by the probability of the third flip landing heads. 1/2 times 1/2 times 1/2. 1/8. What if the events are dependent? What if the second event's probability is based on the outcome of the first event? In this case, the probability of the events happening together is a little more complicated. The probability of event A happening multiplied by the probability of event B happening given that event A happened. For example, what's the probability that you'll draw an ace, hold on to it, and then draw a king? We'll start with the probability of drawing an ace. 4 out of 52 cards are aces. Then, we'll need to calculate the probability of drawing a king, given that we've already drawn an ace, which is different than the probability of drawing a king from a full deck. There are 4 kings left in the deck, and there are 51 cards remaining, since we're holding on to an ace. We multiply these two probabilities together, and we get a probability of 16 out of 2,652, about a 1 in 167 chance. In summary, if you want to know the likelihood of event A and event B happening, you can use the multiplication rule of probability. Make sure to identify whether the events are independent or dependent, and adjust your calculation accordingly. Happy probabilitying! Thanks for watching. Interested in other topics? Let me know in the comments.
Did you understand the given examples? That's great! Let's now have another activity. This activity is called Find Me. So what you have to do is to determine and illustrate what kind of experiment, outcomes, sample space, and event are used in a given problem. Great! Now class, in your own words, can you define the following terms? For our final activity, let's play Fact or Bluff. Outcomes is a process of leading to exactly one of various possible outcomes. Is it a fact or a bluff? Is a bluff. Experimental is an activity with observable result. Is it a fact or a bluff? It's a fact. And for your assignment, I hope you enjoyed our discussion. Till our next fun and exciting lesson.